Hello class of 2018. For this lesson we're looking at using the population parameter p and the normal distribution to calculate probabilities involving sample proportion p hat. So let's take a step back and have a look at the binomial distribution. So your notes will be slightly different, so you need to change these. If p is small, i.e. close to 0, and in our case here we've got n equals 10, it will be skewed to the left, i.e. positively skewed. If p is about 50%, and your notes will say n equals 6, let's change it to 10, it's going to be symmetrical and centered on p equals 0.5. And if p is large, it's skewed to the right, and n in this case is 10, not 12. And p is 0.8, not 0.9. Okay, now if we were to label these, you would have x's along here. But if you divide each x value by n, then you get the variable p hat, which I'm having great difficulties with the hat, but hopefully you get the idea. So 0 stays the same, 1 divided by 10 is the new p hat, 2 divided by 10 is the new p hat, etc. And as a little shortcut, I'm just going to put little dots in because 0.4 is the same as 0.4 if I can get the dots in the right spot. Obviously 1.0 is 10 divided by 10, and 1.1 is 11 divided by 10. Right, so we make use of this as n approaches a large enough number, then the graphs become a lot more bell-shaped and they become much more resemblant of the normal distribution. So then we can use the mean as p, the proportion parameter, and the standard deviation as p times 1 minus p over n. Of course, remember to take the square root. So here we have a question involving a assumed probability, a use of a normal approximation and an n value or a sample size, and a proportion that we're looking for. So let's label it in terms of what we are told. We are told that 60% of people have a driver's license, and that's an assumed thing for the population. So our assumed proportion for the population is 0.6. Then we are told to use a normal approximation, which is helpful. A randomly selected sample of size 200, so n is 200. And we want to find the probability that more than 65% of people have a driver's license. So that means we are really asked to find the probability that p hat is greater than 0.65. So if we use a normal approximation, we start with a mean of p, which is 0.6, and we also have a standard deviation or square root of p times 1 minus p over n, which equals the square root of 0.6 times 0.4 divided by 200. Take the whole square root of that, and that gives you 0.0346. Then you apply your normal cumulative distribution function, where you start with a mean of 0.6, standard deviation of 0.0346, starting value of 0.65, and a maximum value of 1. And so therefore the probability of p hat greater than 0.65 will equal 0.074457, which you round off to whatever the question asks you for. So here we've got a similar question. This one is a assumed population proportion. We have an n value here, and we are looking for a probability that less than 40% will be female. So let's set up our problem here. Let x be the child born is female, and p is given as 0.5, n is equal to 25, and you're asked to find the approximate probability that the less than 40% of the next 25 children will be female. So again, we use our normal distribution or normal approximation. The mean will be 0.5, the population parameter. The standard deviation will be the square root of p1 minus p over n. And we take the square root of all that. So we have 0.5 times 0.5 over 25, take the square root of all that. That gives me 0.1, I believe. And then you apply your normal CDF situation, where you have the mean is 0.5, standard deviation is 0.1, the minimum value for x, which is really p hat, is 0, and the maximum value is 0.4, and so therefore probably the p hat less than 0.4 is equal to 0.158655, which you would round off to whatever you need to round off.